This looks like a quadratic too, right? But what's different about this one from the other one? It's got two different trig functions, right? So we need to make it all one trig function. Which is the identity we're going to use that will help us convert one of those to the other? Lexus? Okay, the sine squared plus cosine squared equals 1 will allow us to substitute for the sine squared, and then we can have all cosine. Right? You can't substitute for cosine x because you don't have a substitution for to the first power. We only have for the squared. Right? So you're going to use that identity, make this 2 times 1 minus cosine squared x. Right? And now we've got our 3 cosine x minus 3. So if it's not all the same identity, you're going to have to do or it's the same trig function. You're going to have to use an identity to substitute so that it is. Now let's simplify, combine like terms. This is 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. Combine the 2 and the negative 3. Negative 2 cosine squared x plus 3 cosine x. 2 minus 3, negative 1. And I can see this will be a factoring problem. And you don't really have to do this, but for myself, I would rather that it was starting with a positive, not a negative. So I'm going to take a step and multiply this whole thing by negative 1. So that instead it looks like positive 2 cosine squared x minus 3 cosine x plus 1 equals 0. And then factor it like a quadratic. 2 times 1 is 2. What are the factors of 2 that add up to negative 3? Negative 2 and negative 1, right? So that would be 2 cosine squared x minus 2 cosine x minus cosine x plus 1. Right, I split up the middle term. When I group it, I'm going to have to take another line to do that. Because the minus, which is in between there, is going to flip the sign. When I put in parentheses, 2 cosine squared x minus 2 cosine x minus, and now when I introduce the parentheses, that's cosine x minus 1. So here, to take out a 2 cosine x, and I still have cosine x minus 1 minus cosine x minus 1. And now last step, 2 cosine x minus 1 times cosine x minus 1. And because this is running on so long, let me try to do this trickery. Sometimes it grabs too much, but that's okay. And now I'm going to do edit, copy, and insert page after edit, paste. There we go. Okay, we didn't want that one anyway. We just wanted that one. And why won't it grab that for me? That's okay. Edit, cut. Okay, so we can work on that up there. Okay, so 2 cosine x minus 1 equals 0. That means cosine x equals a half. Cosine x equals 1. I am skipping a step there. Okay. Where does cosine x equal 1/2? Okay. If you go here. Cosine x equals a half here, right? And it equals a half here. And this problem, when we started it, it said, it didn't give us a limited domain. It said just solve. We got to find all the answers here. So we need to say for this one, for the pi over 3, which was this one right there, then we're going to say x equals pi over 3 plus, and then what will we say after that? How often does it repeat itself? 2 pi, right? Every 2 pi around, it'll get back to that same place. So you have to say n times 2 pi. And then for the other one, which was down here, 5 pi over 3, you have to do the same thing, right? 5 pi over 3 plus n times 2 pi. Right? Where does the cosine x equal 1? At 0, 2 pi, right? So we would just, for that one, you can say x equals 0 plus n times 2 pi, but there's no point writing the 0, so it's just x equals n times 2 pi. So those are all the answers.